Age problems can be approached in the same way as number problems if we just observe that the names of the people involved are our variables. I'm going to let B stand for Bill's age and T stand for Tom's age. The sentence, Bill is 6 years older than Tom, can be interpreted as one number, B, is 6 more than another number, T. This is simply a statement of fact from a particular perspective. Bill is 6 years older than Tom. Bill's age right now is the same as Tom's age right now plus 6. Set that statement aside for the moment, and let's take a look at this other sentence. 3 years ago, Bill's age was 4 times Tom's age. The word was here is the past tense of the word is. So the was is where our equals is going to go. For this sentence, we're looking at Bill's age 3 years ago. That was Bill's age now minus 3 years. Tom's age 3 years ago was T minus 3. Tom's age now minus 3 years. But these are not equal. What makes them equal is identifying that Bill's age 3 years ago was 4 times Tom's age 3 years ago. Now I have two equations, one for each sentence. This statement goes with the first sentence, and this statement goes with the second sentence. As we did in the last example in the number problems, let's make the observation that B has a value equivalent to T plus 6. So wherever I see a B, I could replace it with T plus 6. Let's do that now. Let's rewrite this equation as B minus 3 equals 4 times T minus 3. But instead of B, we'll write the equivalent value for B, which is T plus 6. Now, if I tidy up this equation, I get T plus 6 minus 3 equals, for my left-hand side, and for my right-hand side, I get 4 times T minus 4 times 3. Combining like terms on the left, I get T plus 3 equals 4T minus 12. And now I can solve this equation using the techniques learned in Chapter 1. Let's subtract T from both sides. That keeps the T's positive. It's certainly not the only way to do this. I could have chosen to subtract 4T from both sides instead. Let's go over here because I've run out of room. Here's that last line again. Now here are my T's. Let's add 12 to both sides. And I get 3T on the right is equal to 3 plus 12. Finally, dividing both sides by 3, I get T equals 5. And it looks like that's my answer. We'll need to go back and make sure that we've answered the question correctly. Bill is 6 years older than Tom, and 3 years ago Bill's age was 4 times Tom's age. Find the age of each boy now. Well, I've done that for Tom. Tom's age now is 5. What's Bill's age? I haven't answered that question yet, but I can quite easily. If Tom is 5, then I can substitute the value of 5 for T into this other equation. And I get B equals 11. So my answer is that Tom is 5 years old and Bill is 11. That's actually my final answer. This is the only age problem example in your textbook. Look for other age problems in the worked examples video for Part B.